I always speak with my Arizona license and not my Texas medical license, because Texas does not allow its physicians to talk about things that aren't considered standard of care medicine. And so I speak with my Arizona MDH license. One of the things that I would like to share with you is the concept that if you don't die from trauma, then half of the people in this room will die from cancer, and approximately half will die from cardiovascular diseases, whether it's heart, brain, or diabetes. And so what's the difference between being alive and being dead? It's simply a matter of whether or not you still have voltage in your brain and the rest of your body. So because that is the bedrock of whether you're dead or alive, it's important to take a look at that system. And the reality is that all chronic disease begins when an organ flips the polarity of its power supply. So let me say that one more time. All chronic disease begins when an organ loses its power because the power supply flipped its polarity. So because that is the origin of it all, it's important for us to understand what it is and what we can do about it, because that allows us to gain control of the rest of our lives and the lives of those we love. So if you take a look at this cemetery, again, everybody in there died, if they didn't die from trauma, died because they flipped the polarity to one of their vital organs. Everyone in that cemetery. So if you want to take control of your life, your loved one's life, you need to really begin to understand the role of voltage in the body, because that's the difference between being here and not being here. And of course, the role of regenerative medicine is to take someone who is ill, such as the beautiful example we just got of this gentleman getting his life back, and using stem cells and other modalities to get their lives back. And this is important for you as well as your patients. So again, you might wonder about this ophthalmologist, and this is my wife and I doing surgery many years ago, because that was my specialty. And I really had a great time. I was healthy, had a great practice, had an international reputation, had a family that loved me, etc. So the American dream. And then slowly I just faded away. And so, you know, that's going to happen. It is happening to many of you. You just feel like, I'm just not as good as I used to be. I'm tired. I can't think like I used to. Can't sleep like I used to. And you think, well, I guess I'm just getting older. No, you're not just getting older. You're losing your voltage. And this is, of course, what happened to me. And so I started healthy and then just faded away over a matter of years. And so I did the majority of the research in the laser that's used in LASIK surgery. And I had a lot of fun doing that, but we didn't know that it wouldn't kill viruses. And so I used it to carve the scar off of the cornea of a man with leukemia, released those viruses, went through my mask into my brain, and I got encephalitis. And so I went to the head of oncology and hematology at Southwestern Medical School, at Harvard Medical School, and at the NIH, and they all said, well, you have 3 viruses in your brain, go home and die. Well, I didn't really want to take that advice. And so I had 2 or 3 hours a day in which I could understand a newspaper, and then like a light switch would go off, and then I couldn't understand it anymore. So I decided that during that few hours a day that I could really think, I had to try to figure out how to get myself well. And that started me down this journey to where now I am not practicing ophthalmology or plastic surgery. I'm considered an electrophysiologist. And so, what is electrophysiology? Well, it's the oldest form of medicine. The oldest medical text we have is 2,000 or 3,000 years old, the Yellow Emperor's Book of Acupuncture. And of course, they were practicing electrophysiology all that long ago. And so, because every time I start talking about electrophysiology, most of my colleagues think my cheese has slipped off the cracker. And so I wanted to just give you an example. I've always been hesitant to tell people about anything that may look like I'm boasting, because that's not who I am. But so I find I have to do that in order for people to really realize that my work has been evaluated around the world. I've been fortunate to lecture to over 1 million people in 16 different countries, and I've had a lot of funds doing things in medicine, and I also have received awards, which means other physicians have evaluated my work and found enough of it to be giving me various awards, and so I'm grateful for that. One of the ones that surprised me is I got a call to see if I would accept an award from the Pope for my contributions to medicine, and I was greatly honored by that, but surprised since I'm not Catholic. Yeah. So the reality is that all of our cells are designed to run at 25 millivolts. And when they wear out or get damaged, you need 50 millivolts to make new cells. And so where does all that voltage come from? Well, it turns out that our muscles are rechargeable batteries, and they're also piezoelectric. So what's that funny word mean? If you take a piece of quartz and squeeze it with a pair of pliers, it emits electrons. Well, muscles, and that phenomenon is called piezoelectricity. So if you move your muscles, they are actually generating electrons. So our muscles are designed to generate electrons and to store them. And so then our muscles are stacked one on top of each other in a very specific order in order to create a power pack. So every organ in the body has its own power supply, and a stack of muscle batteries, what's been called an acupuncture meridian. And so here, just an example, I've isolated the muscles in one of the circuits. And so you can see that these are stacked one on top of each other, and this becomes a power supply for the various organs. Now, here's the study, by the way, showing that our muscles are piezoelectric. And so here are the various circuits that I've isolated for you. And so the issue then is that we have several batteries in the body. The largest ones are our muscle battery packs. Those go through our teeth down into the body. So included in every circuit is a specific tooth. And then it goes down to the cell membrane. Excuse me. Our cell membranes are actually capacitors. So what's a capacitor? Capacitor is like a battery, except the difference is when you ask a capacitor to give you electrons, it gives you everything it has in a burst, and then it has to be recharged. Whereas a battery can give you voltage slowly according to demand. But all of our cell membranes are actually little batteries. And then just inside the cell membranes and underneath the cell membrane is a gel that's called EZ water, exclusion zone water. And it is also a electron donor. And then, of course, you go on down into the cell, and you end up getting to the mitochondria, which everybody here is familiar with. So the mitochondria is just the final common pathway battery, but it all begins in our muscles. And so here it kind of simplifies that a little bit in that you see our muscle battery pack, our teeth, our capacitors, and our cell membranes, and eventually the mitochondria. And of course, the mitochondria also contain another rechargeable battery system. If it's charged up, it's called ATP. If it's discharged, it's called ADP. And because it's a rechargeable battery, we have to have a battery charger inside of our mitochondria. And that's called the citric acid cycle or the Krebs cycle. And so for every unit of fatty acids that you put into this battery charger, if there's oxygen available, you get enough electrons to charge up 38 of these rechargeable batteries. If oxygen is deficient, for every unit of fat you put into the battery charger, you can only charge up 2 batteries. So that's how one of the ways that oxygen concentration affects our voltage into our cells. And so again, it's well known in battery technology that if you take a rechargeable battery and you drain it to 0, it flips its polarity upside down, as you see here. So normally the polarity should spin clockwise, But if you drain it to zero, it spins counterclockwise. And of course, the problem is if you take a battery that's flipped its polarity, put it in a battery charger upside down, it won't take a charge. You put it in a flashlight upside down, the flashlight won't turn on. And if it's in one of your acupuncture battery packs that provides voltage for that organ, if it flips its polarity, now that organ doesn't have adequate voltage to work, and therefore it's going to fail.
Mention too that your voltage directions underneath, that when you're clockwise rotating, that you're giving off electrons with the negative charge. When you're counterclockwise rotating, you see your arrows under, it's telling you what you're doing. You're robbing electrons. This is why our acupuncture, this is why muscle testing and white physiology works. We flip our aura.
Thank you, Richard. So obviously there are a lot of nuances to this, but I normally take 3 days to teach physicians how to do this, and I have 30 minutes. So now it turns out that that most everybody knows about electromagnetic energy and radio waves and electricity and so forth, but very few understand about the voltage in a liquid. So as you can see in this liquid over here, we have plus and minus. And so again, we have polarity into our liquid. But the reality is that that pH is simply the measurement of voltage in a liquid. Let me say that one more time because it opens up a whole new scope for you. pH is the measurement of voltage in a liquid. If you take a pH meter and measure, pH meters measure in millivolts. Did you know that? They measure in millivolts. And then it's got a switch on the side. When you switch it, it will do the math and turn that into a logarithmic scale that's called pH. But it's much easier and understandable if instead of using pH, we use what it really is, which is voltage. So by convention, if what is being measured is an electron stealer, you put a plus sign in front of the voltage. If it's an electron donor, you put a minus sign. And so again, if you measure the electron stealers go from plus 400 millivolts, and electron donors up to minus 400 millivolts. And of course, if it's zero, then that's a pH of 7. And so here you can see the difference between electron donors and electron stealers. For the lack of time, I'm going to move on a little bit here because I've got so much else I want to try to share with you. When you see this slide, you might ask the question, didn't anybody ever teach you not to put so many numbers on one slide? Well, I did it on purpose. What this shows you is that, again, cells are designed to run at a pH of 7.35 to 7.45. Well, 7.35 is the same as minus 20 millivolts of electron donor, and 7.45 is minus 25 millivolts of electron donor. So our cells are designed to run between 20 and 25 millivolts of electron donor. Now, oftentimes people get confused by saying, oh, that's not right. Cells run at 80 or 90 millivolts. Well, that's true if you take a cell in a petri dish and you put an electrode inside a cell and an electrode outside the cell and measure across the cell membrane, you get around 80 or 90 millivolts. But every cellular biology book will clearly tell you that the environment in which cells are supposed to work is 7.35 to 7.45, which is minus 20 to minus 25 millivolts. And then as voltage drops, as you can see as it goes down here, when it goes past zero, it flips its polarity. And it was shown by Keith Brewer in his work in the 1980s that cancer occurs at plus 30 millivolts. So again, we come back to the fact that cancer only occurs when you flip the polarity. So what I want to emphasize at this moment, and then I'll get into the stem cell stuff, I would predict that essentially every woman in this room has thought about, gee, I wonder if I'm going to get breast cancer. Well, the reality is that it's almost impossible to get breast cancer unless you flip the polarity in the stomach acupuncture circuit, because that's the power supply to the breast. So again, if you want to reduce your risk of having that happen to you down to near zero. All you have to do is learn how to measure that circuit, measure it every morning, every afternoon, which takes 5 seconds. And if you keep that circuit on, it's almost impossible for you to get breast cancer. Is that worth the time that you've spent today coming? Well, the same is true for men. The prostate happens to be on the same circuit, the stomach circuit. And so also, if you don't want to have a heart attack or a stroke, all you have to do is be sure to keep the heart circuit on. And again, you measure it in 5 seconds, which I can teach you how to do. And then if you find that it's flipped its polarity, I can show you how to use scalar energy to flip it back on, and then electromagnetic energy to charge it up. So I hope some of you will come by our booth afterwards and let us show you these things. But again, what I'm trying to do is to tell you that it's in your hands, not your doctor's hands. It's in your hands to decide if you want to take the time to learn how to do this, so you can save the misery of having all these illnesses that are otherwise are going to surely get you. Now here we kind of look at polarity again, and what we see, of course, is the one that we all are familiar with. Batteries have a polarity that allows our lights to light up, but most people ignore the fact that all chemistry is polarity. So about half of our elements on the periodic table are plus, and about half of them are minus. That's polarity. And so the reason that chemistry works is, again, polarity. So again, polarity basically controls everything in the universe, everything from our chemistry to our weather. And you can see the Earth itself has a polarity. And by the way, the difference between men and women in their acupuncture circuits is in their reproductive system, because the males, as you can see, have a plus polarity, and the females a minus polarity, which, by the way, explains social behavior. Now, I want to point out the amazing work of Dr. Christian Bohr. This is called Bohr's Law, or Bohr's Effect, and all of us who have medical degrees were taught this in freshman medical school, but often we forget it. The reality is that for oxygen to hook to hemoglobin, you have to have 34 millivolts in the heart, in the heart circuit, in order for oxygen to attach to hemoglobin. So this was important, of course, during COVID, because people would go into the hospital and they say, oh, well, your oxygen saturation is low, we're going to put you into ICU and stuff a tube down your throat and pump oxygen into your lungs. Well, 80 to 90% of the people that did that died because their physicians had forgotten Bohr's Law. So you can pump all the oxygen you want in the lungs, and it won't attach to hemoglobin unless you have 34 millivolts in the heart circuit. Is that important?
Yeah.
Okay. Now, let's assume that you have 34 millivolts. Oh, by the way, let me just tell you how important that is. Have a friend up in Utah who's an FBI agent. He went into the hospital with COVID, and they said, well, we're going to vaccinate you and put you in and intubate you. And he said, no, and no, thank you. And they said, okay, we'll put you in that room over there till you die. So he called me and said, hey, my oxygen saturation is running around 70 when I'm at rest, and around 60 if I go to the bathroom. And they tell me if I live through this, I'll be on oxygen the rest of my life. Fortunately, had the devices that I developed. I said, okay, well, just take and put a patch here on your wrist over the heart circuit and start putting voltage into your system, and use the device that flips polarity back to normal. Just lay it down between your legs. And so he called me a couple of days later and he said, well, in 24 hours, my saturation went from 70 to 80, another 24, 80 to 90, another 24 in the high 90s. So they sent me home, and I'm hiking in the Utah mountains without oxygen. So again, Bohr's Law. And so the other part of Bohr's Law is that okay, let's assume that you're running at 98%. The blood's going around through the body, circling around. It won't come loose where the cells can use it until the voltage drops down to here to around a minus 11 millivolts. So how does that happen? Inside our red blood cells, we have the thing called the carbonic acid buffering system. And so the CO2 that comes from our metabolism goes inside the red cells, and basically bicarbonate, which is basically baking soda, will convert the CO2 into hydrogen. And that hydrogen is able to drop the voltage from 34 millivolts down to the 11 millivolts, so it comes loose so you can use it. And so one of the more important things that you can do for yourself, particularly if you're past 40, is to realize that your kidneys have trouble making enough bicarbonate when you get past 40, so that you become progressively hypoxic. And so just take a quarter of a teaspoon of baking soda and a glass of water every day, and it's been shown it'll increase your telomeres and make you live longer. Baking soda, 40 cents a box. Okay, so a great way to keep yourself going. Okay, so what I'm trying to emphasize I've got, 8 minutes left. We start off with a battery pack, which if you have inadequate voltage, then you don't have the minus 25 millivolts it takes for cells to work, and you certainly don't have the voltage that it takes to make new cells. And so you begin to have progressive loss of cells. And then over time, because of Moore's law, as the voltage drops more and more, you begin to get more and more hypoxic. You end up with cancer. And this is Otto Warburg that showed us and got a Nobel Prize in 1931 for saying cancer is no longer a mystery. It only occurs when cells are deprived of 60% of their oxygen requirements. Boom, there it is. So what controls oxygen? I just taught you. Voltage. So if you keep your voltage normal, you keep your oxygen normal. You keep your oxygen normal, then you don't go there. Okay, so let's jump forward a little bit now to, in the few minutes I've got left, and because I want to share with you about the healing process. So if we fall down and just scrape the skin off our knees, and we have 50 millivolts in the power supply that's in that area, we will get the 50 millivolts and we'll simply make new cells without any scarring. Now, if we have a deeper wound like this, or we have an organ that's scarred, what's going to happen is it's going to put fibroblasts in there to form a scar in order to make this strong. And then what you see then is, because you get the fibroblasts, you're going to scar, and you'll end up with a permanent scar. Now, if you happen to be able to make stem cells or put stem cells in there, then it will scar, the scarring will not occur. Instead, you will have normal healing because it's able to regenerate the tissue. So again, what happens in healing is controlled, as I'm going to show you, by the voltage. Now, here's an important thing to understand, and that is fibroblasts change into stem cells. So again, the wiring system of the body is our fascia. So the fascia goes around the muscle battery packs, goes down to the fibrous capsule around every organ. From the fibrous capsule around every organ, there are little fibers that go down to every cluster of cells. So that's the wiring system for the body. And now, that means that because the wiring system is also providing fibroblasts, if we can signal it properly, the fibroblasts will turn into stem cells. Neat, huh? So the issue is, okay, what allows that to happen? Well, here are the studies, by the way, that are published about them turning into it. So let's take a look at the system that nature provided for us. God gave us the example of how to do regenerative medicine, and he did it with the salamander. And of course, this is Robert O. Becker, which many of you have read his book, The Bioelectric. And so if you take a salamander and you cut his arm off, he grows a new one. You poke his eye out, he grows a new one. So no matter what you do to the salamander, he can keep growing new parts. So Becker was an orthopedic surgeon up in Rochester who noticed that humans, if you lose a piece of bone, you can make you'll make more bone. But if you lose anything else, you heal with scarring. So he wondered why the salamander could do it and we can't. And so here you can see the salamander, the arm cut off at 48 hours, You see the bone there, and you see the retracted muscle. And here you can see, and now we are at 18 days. You've got this, it's healed around the end, and you're beginning to make stem cells. And then here we are at 42 days out, and it's got a new leg. So how did that happen? Well, if we can understand how the salamander can do it, it helps us understand how to help humans do it. Now, if you look at, this is the recordings that Becker made, and what you see is that a salamander runs at 10 millivolts, whereas a human runs at 25 millivolts. But anyway, if you cut his leg off, you can see the voltage drop down here until it gets down to plus 30 millivolts. And then a switch causes the voltage to rise, and when it gets up here, you make the stem cells, and now it grows a new leg. Now, interestingly enough, the frog is another amphibian, but it doesn't do that. If you just cut the frog's leg off, it will just come up and scar. But one of Becker's residents embedded a watch battery in the stump of a frog, and the frog grew a new leg. A watch battery. Also, work is being done right now at Yale University, and they are shown that there are other things that will do this. For example, you can put a poultice containing progesterone, and the frog will grow a new leg. They're also doing other interesting things there that I don't have time to tell you about, but they've shown that DNA is not what's controlling any of this. In fact, what they've done is they've taken a worm and by changing the magnetic field around, which is the template in which we all grow into, by changing that magnetic field, they created a new species of worm that has the same DNA as the old one. So now we have two different species with the same DNA. So our thinking about how DNA controls everything goes right out the window. So what I did is I thought, well, let me take the work of Becker over here and multiply it times 2.5, so we get to the equivalent voltages for a human. And what you see is then that the human runs at minus 25 millivolts, and it drops down to plus 75 millivolts, but then it kicks back up and goes up. If we can get up into the minus 75 millivolt range, then it grows a new leg. So we need to look at these numbers in humans because, again, God gave us a salamander to understand how regeneration works. So one of the interesting things is to consider Procaine. Now, as most of you know, Procaine was developed by the German brother, the Hunicke brothers, and developed this part of science called neurotherapy. That's done by about 40% of European, Central and South American doctors, not commonly done in this country. But one of the interesting things is that if you look at, you change these voltages that Becker gave us back into pH, you can see this is a pH of around minus 5 something, and it goes up to a minus, this is plus, and this goes up to minus 8 or so. And so one of the things that happened to me is that about 20 years ago or so, I had a retrobulbar stroke in my left eye, and which blinded it, but the lesion is back here behind the eye at the chiasm. A few years ago, I got COVID, which took out the lateral geniculate body, which is the CPU for all of vision, and took out the vision, a lot of the vision in this eye. And so here are the Hunicke brothers, by the way. So what happened is that I got stem cell therapy from 2 different centers, and didn't really get much improvement of any kind. So I was I'm blind in this eye, 2400 in this eye. And so I began to think about this voltage thing, and so I simply had one of my colleagues inject some Procaine onto the orbital floor. And so in 1 hour, I went from 2400 to 2050. And all they did was put basically 1 drop of Procaine on the orbital floor. Wow, I thought. So what it became obvious to me that I wanted to share with you is that if we fix the environment in which we're going to put stem cells and pay attention to what's going on with the voltage, we have the ability then, I think, to combine stem cell therapy and neurotherapy to create the kind of environment that allows us to instead of injecting stem cells where voltage is low and thus oxygen is low and thus fungus is there, and see if we can clean up that environment and then use the Procaine to cause the environment to be like the salamander, and then 24 hours later give them the stem cells. It's my feeling and prediction, particularly from my own experience, that we are going to find that things work better. Don't want to mix Procaine and stem cells because of the acidity of Procaine will damage the stem cells. And so, okay, the floor just opened up and I fell into the basement, so thank you very much.
And York's like,